Panimalar Institute of Technology, Chennai, Tamil Nadu in association with IEEE Teams Madras Chapter, PIT EDC, IIC, IEEE SB, IETE ISF welcomes you all for the second phase of AICT sponsored short-term training program on Mission Vision for entrepreneurs launching startups with low seed fund. It is my immense pleasure to welcome our today's presenter, Dr. Athif, founder, chairman, ABE Semiconductor Design, Chennai. Technocrat and most importantly, the combination of teacher and the industrialist. With the span of 15 years of journey, leading nearly 40 plus research teams across the nation, designed nearly 50 plus technology transfers and products and handled nearly 200 CBU. As teacher, he has conducted nearly 200 pan-India workshops, trained nearly 5,000 engineers, and awarded as the best project guide by Renesas Japan in 2008 as the Intel Innovator in the year of 2016. He has designed major products such as IoT-based Rementia caregiving systems, single-board computers, hardware-based machine learning algorithms for healthcare systems, wearable devices, being recipient of National Center of Excellence in Teaching, New Delhi in 2016. He is currently as a IoT and man-to-machine architect involved in the research technology which are beyond the imagination. I welcome you, sir.
Hello. Thank you, ma'am.
Now I hand over the session to Dr. Athif.
Yeah, actually, very good morning to one and all here. This is Athif, Chairman and Managing Director of AB Semiconductor Designs. It's a great privilege to be the part of this program for the machine vision system for entrepreneurs and for kind of an seed funding and everything. But still, I'm not rely on the seed funding actually, right? It's a bootstrap company. We are working on we have been a bootstrapped actually, like we don't rely on any external funding. We generate our own internal funding for our application. So I can share you more on about the bootstrapping and how we started later on my session, because we are working for Google for the kind of developing a version system for the for industrial application. I don't want to reveal the application actually. So for an industrial application, we are just developing a lot of analytics engine based on the real-time video actually. So here the session is going to be like the challenges what we face. In first thing, I want to discuss about the challenges first of all. What is the vision system? Everybody is working on vision system right now, but what exactly the vision system is dealing with that? So what are the exact problem what we have in the field actually? What is the expectation from the market? What is the market survey we have taken actually? So we will discuss about it. And second point is like we will discuss about the different algorithms which is utilized, how the design challenges has been overcome with the help of the algorithms, what we have to develop it and where to deploy it and test it. So this is a logic. And when you want to pitch for the seed funding actually, so what are the things you have to remember while doing a seed funding mechanism and everything. And like and after that we will discuss, we'll have a query sessions with you. I'm happy to share you my thoughts with you guys actually. So actually like it is my 100th webinar actually for this 8 months. This is my special webinar, that is I'm giving it's a 100th actually. 100 webinars are over and this is my 100th webinar actually. So here we are going to have this sessions for you actually, so you can discuss with me with a lot of problems what we have and we can try to find a solution for that. So before moving on to the session directly, let me go for my presentation. It is not going to be a presentation something on that. It is purely based on what we talk about, like whiteboard session, everything, because some of them like we would have seen previous session, I used to take some case studies, but in this case we are going to have a detailed case study of everything about the video analytics and where to integrate and what are the design challenges and everything, right? So we'll start with the basic thing actually, right? The basic mechanism what we have and what are the things which we have made on. The first thing is about as we talked about, you can very well refer for our website actually, abgroups.com actually. And as I told you earlier, like we are working on particularly on AI, so artificial intelligence actually. So and we are working on two diversified areas. One is on the artificial intelligence as a software and artificial intelligence as a hardware. So we are the two separate areas where we are working over here. And in the hardware division, in the kind of a hardware division, we used to we used to work on the implementation of AI on the algorithm. So that algorithm, like algorithm on the hardware, we'll discuss about how it is integrated, design challenges and everything. And we are developing an apps, mobile apps, basically on AI. And we are like working on the kind of an application and working on the kind of the logic what we have. And it is purely on the developing an algorithm for certain kind of an software based applications. So that too for the education system. So these are the two areas we are working over here. And this is going to be like I'm going to share these two areas also. What are the design challenges and how do we face on to the presentation? Let me discuss about the design challenges what we have in the video analytics, right? So it is going to be a Q&A session. So I don't want to be the one-time explanation for you guys, actually just running the PPTs, seeing what is what. I need really a healthy discussion with you guys. So please be interactive because we are very small in number. We can interact with each other. So we can discuss about the time, discuss about the ideas what we have, right? So please be interactive, and just you can discuss me after whatever the doubts you have. You can discuss me afterwards, right? The first thing is about us. We want to discuss about you the major and most important application what we come across here. First thing is about what is the design challenges we have right now. What is the exact design challenges when you design a vision system, and what is the real expectation from the industry? What is the real expectation what we have? Because every time we will be working on a kind of an application on basis of the video, and we do some mask detection and everything. But what is the design challenges we have here? What the expectation when we work on this? Let me explain you first, right? First thing is about, maybe some typo is, sorry for that. So first thing is about, right, whenever you develop an algorithm, whenever you have lot of machine learning, deep learning algorithms, so what is exactly we require? So how to train it? What are the logics? The first design challenges, developing an algorithm. I'll talk about developing an algorithm. So what is the design challenges we face here is the development of algorithm that is resolution independent. This is most important. What is this actually, right? So what is this exactly is something on resolution independent. I need a camera. I need not require any high definition cameras or to capture and to make it out. If I train with one kind of a camera on my, or even for example, if I train for a high definition cameras and keep it on my cloud or a data in a hardware, my algorithm should work for any type of a cameras. This is the most important vision challenges what we are facing today. So my system, because in order to reduce the cost complexity, in order to reduce the mechanism, there is a one-time training. First of all, there will be a one-time training, and second thing is about that one-time training should be supported to all kind of a cameras. So this is the most important logic. Higher to lower is possible, but lower to higher is a little bit difficult. So, but resolution independent cameras and working on the resolution independent algorithms are the most important for working for designing of an algorithm. Because when you talk about a vision system, or when you talk about your machine learning or a deep learning or any kind of AI based mechanism, so this formation of this algorithm plays very important role. This plays very important role. So that is the kind of an application what we have right now for this first. And second design challenges, the most important design challenges, working on live streaming of video. This is most important for us. Live streamings of video. So working on live streaming of video in sense, because what we do in normally is like we just capture the image, we do sort of frames, and then we'll just get the features, store it on any storage, and we do a lot of application. But here, working on the live streaming of video is important. The live streaming of video is most important for us, because working on the live streaming is a design challenge for us. It's a most important design challenge for us. So this is the second point what we have, the live streaming of videos. Third point what we come across here is the security issues. Most important. Whenever we work on the videos, the customer will not accept to store their faces. So here the security policies has to be integrated along with the live streaming of videos. This is most important. So the security policies are most important when you work on with industrial kind of an application. So how it is developed and what are the logics which you have taken care, that has to be mentioned clearly. So the security is most important for these cases. So the three design challenges which you are facing technically, one is resolution independent, live streaming videos and working on live streaming videos, and security, that is making a security that is following the security policies for the applying the ML or DL on the videos or images. So this is most important design challenge what we have. And finally, like handling the bandwidth. This is most important because nowadays we work on IP cameras. So this is most important. So your mechanism should able to understand. It should able to understand. It should able to work on for a kind of a bandwidth, and it should have a good bandwidth and live streaming of video, because we talked about live streaming of video. So you should go by hand about the handling the bandwidth for the particular network mechanism. So these are all the challenges what we faced, and I just list out what are all the things which is required for here. The fifth point here is again most important thing is when you design an algorithm, for the machine, decide where it is going to be ported, whether it is hardware centric or it is a cloud centric. So please remember all these things, because when you work on the hardware centric, the porting of these kind of machine vision system or a porting of the artificial intelligence on my hardware is complex, but still we have a solution. So please decide where to port your intelligent algorithm for the video analytics. So whether it is a cloud centric, whether you want to put it on the cloud centric, well and good. Okay. So what are the challenges we face here? We'll discuss later on. So first decide what is where to put up. One is with the hardware centric, or second is your software centric, that is cloud centric mechanism. So this is all the logic which we have to take care about the mechanism. So these are all the things: the resolution independent, live streaming video, security, bandwidth, and hardware. So these are all the things which is required for our application. So these are all the things which is required or design challenges whenever you start with the vision system. So first thing is about the vision system. This is the challenge what we face right now. The second point what we want to come across here is how to design this. So how to design it? We know this is a camera, so we talk about forming a resolution independent cameras, but still how to design this and how to form an AI algorithm. So now we'll move on to the algorithm side. What is the algorithm and how it is going to be designed here, right? So now the algorithm formation is required for us actually. So we are going to see how the algorithms can be defined. So these are the design challenges. Please keep it in your mind. What are the design challenges when you work on the vision system? Now, how the vision system is integrated with an algorithm. So this is most important for us. So we'll talk about this. So before that, we must know about what is AI and what are the applications of artificial intelligence for a solution. So this is the models which we have been integrating over here. The first thing is about whenever you talk about the vision system for an application, please remember these blocks which is required for that. First block is data model. The data model is most important for us, and the data model will consist of the cameras connected with the internet. So this is what we talked about, or cameras with the boards, right? So cameras with the boards actually. So so this is the logic which you have to be taking care. So nowadays transferring a video over the network plays an important role. So that plays very important role for us. So that is the logic which we have to be taking care about the mechanism. So the data model is important. So the data model is very important. So as we talked about, it is resolution independent cameras. So we need a camera. I don't refer the camera what is going to be then, because we are working on different algorithm. So that camera should be able to capture the video, and it should be stored in some places. So here the IoT comes into the picture. The Internet of Things comes into the picture. And primarily for this kind of an application, video over IoT plays an important role. And nowadays IoT has now been replaced with streaming the videos over IPs. So this is most important. The data model is required for a kind of an application. So you have a data model for that, and you have a user inputs for to find out a solution, and then this user input will decide you the where to fix up the dimensionality of area and how many cameras are required. Everything can be designed and it is connected in IP, and these all the cameras, live streams, videos can be stored in your database collection, and from the database collection you can able to extract the features, because it is all about raw data which is stored here, and the videos we have to convert into the frames, and the frames we have to extract the features, and from the features we need to go for the learning model. So this is where our learning model goes here. This is where the learning starts over here. This learning model is nothing but implementation of your machine and deep learning logic. It is the application of machine and the deep learning logic, and we have another call that is a reinforcement mechanism. So we have different groups to be solved and different application to be made over here. And finally, the decision box. So the decision box are nothing but which has been taking place for a training mechanism. What we do normally here is we just have the algorithm. We'll collect some 1,000 data, and out of which 70 will be used for training and 30 will be used for the testing. But my suggestion is train your data with 1,000 and test it in the real-time scenario. If you can test it in the real-time scenario, it can give you the better picture about the logic. So this we have to understand clearly. So every time should be tested in the real time. So it is not meant for only for like we have a group of data and we stop only here. We should not stop here. We should extend to the decision box that how it has been working and what is the logic it is to be working on this. So the data, so I repeat once again, cameras, every cameras. So decide your area and decide your number of cameras, place your number of cameras in an area, stream your video to the IP and get the video to be stored in your cloud or a database. And from that, work on the video or by converting into the frames and extract the feature what is to be required. And from then you just use your machine and the deep learning algorithms which is required and go for the real-time solution. So the data collection is required, and from that we need to go for the intelligent learning, and then we can go for a decision box. The decision box is nothing but the checking in the real-time scenario, So this is what the logic which is to be taken over place. So here we have the schema for that, and we are going to integrate one by one for a solution. So one by one for a solution. So now we are going to check forward for a kind of a mechanism and kind of a logic what we have. So next application, what is required is we are going to formulate a learning model. Because this is a schema you can utilize for any kind of video analytics and everything, but this how it can be integrated. So here the selection of machine and the deep learning is most important. So where do we choose this machine and deep learning? Because you have heard so many times about these words and so many times about this definition. Let me bore with you with one point. Machine learning. So select the volume of data and choose which volume of data can be utilized for that. If the volume of data is less, you can go for machine. If the volume of data is high, you can go for a deep learning. Generally, for the kind of a video analytics, I prefer to go for a deep learning logic, right? So we'll see how it works with what is the mechanism and why machine is most important. So we'll normally go for a deep learning logic as far as the video analytics are considered. And second important application is the feature extraction. Why I prefer a video analytics over the features? Because the features I have to do separately for a machine and I have to integrate for the logic. That is, I need to explore a new algorithm for feature extraction, and I have to combine or integrate with the machine learning to produce a good results. So I have to work separately on features, feature extraction method, as well as the algorithm, because these two should go hand by hand, so that it can able to produce a good results. So this is one kind of machine learning approach. Second, regarding the deep learning, what is all about the deep learning is deep learning will have the integrated feature extracted. So we will work on a kind of a feature extraction, and that feature extraction will be utilized for a kind of an application. We'll discuss you about the concepts, right? So this is how the logic works on. So now we'll go for a selection of algorithm, for what kind of algorithm you have to choose for a kind of an application. So when you learn about the mathematics behind everything, this is going to be the problem for us actually. So when you want to what are the algorithms which is required and everything, this will be the clear thing what we have and what we have to experience. So in order to make you to understand the basic thing, because I prefer make you to understand, so I'm going to take this film for your case study. right? So we are going to see in detail about the vision system as well as with the selection of algorithms based on this film. This film was Endiran, which was released in 2010, starring Talivar and Aishwarya Rai. So this I considered as a encyclopedia for your artificial intelligence algorithm. Right, so because this film will have lot of mechanisms, lot of algorithms which is integrated. I don't know like whether the writer has wrote this, writer has made this kind of keeping in the algorithm, but in the concept. But still, I explored the algorithms over in a different things. So by seeing all these things, you can also able to learn what is happening, and you can able to substitute and see what is there in the application. So we are going to see the movie. Sorry, there was some network issues actually, right? So disconnected. So here, like we checked out, we just made here as this movie actually. Like we are going to start this movie, and we are going to check about this logic. Actually, we are going to have the sneak peek of this presentation is going to be taking about this movie. So what we are going to do here is like we are going to check it out. Uh, we are going to play the video and see what is happening, and then we are going to derive, and we are going to identify the problem and how it is derived with our algorithm, and how this algorithm plays a very important role for the kind of a solution. This is what we are going to see. So now I'm going to play the video for you. Please watch the video. Don't worry, no worries, there is no kind of audio or video, that is not a kind here. Just please look out the video. We'll have a Q&A, and then we will derive an algorithm. So here we go for the first case study about the vision system. So there comes the video for you. Please watch this. So the best for vision system and algorithm working over here, analytics, give you the pretty clear picture. Let's see what is happening. You can see one by one application here. So you would have seen this movie so many times and everything, right? My basic question is, what is the problem you identified in this scene actually? What is the exact problem what we have come across in this scene? We need some answers, guys. What is the exact problem what we have? What is the exact problem?
So he's trying to identify the human and the machine.
That's
He
fine.
wants to
That's good. Yeah, that's fine. That's good, right? Any other answer? But there is some important problem over here. But I'll go with your answers. That's good actually. Right? Good. Next. Anything? Any answers, guys? Any identification here? Some answers, right? So got good answer actually. I got some good answer actually, right? Any answers regarding that? Robots able to rotate their heads. Okay, that is fine. That is final ultimation, right? But human not. Okay, fine. Okay, then the problem. See, the problem human can't able to rotate is it's not a problem actually, right? It's a nature. But exact problem. Why the AI has to play a vital role here? Any answers? Any answers, guys? Okay, so we'll move on to this. So next query is going to be a Q&A and you people have to answer it, right? So first problem, whenever you talk about the design challenge, what we have, first thing about this, we have to, whenever we fix up this algorithm and the data, we need to take about the problem statement. What is an exact problem? I'll go with a first answer because there requires an identification of a human in the machine. But exact problem what we have is we need to identify the human from similar robot. This is the logic. This is an exact problem what we have. What is the logic which take place here is because when you consider this scene, there is 100 these actually 100 robots are there, and all the 100 robots are same, and from the same robot I need to identify difference. This is the most important problem what we have right now. This is the logic what we have, and this is the mechanism what we have right now. This is the logic what we have right now. So the logic which is to be taking place here is very simple. So we need to identify the difference of data from the similar data. This is the most important problem what we have right now. It is well and good, it should be identified. We don't have the problem that out of 100 cities, 90 are robots and 10 are human. That is not the case here. The exact problem what we have is all are similar. All data are similar. But how to find out from the similar data? So this is the logic what we have to come across, and what is the logic which we have to be taking place here. So this is the logic which you have to be taking care, and this is the mechanism what we have to take over the mechanism. So now the logic, how it can be solved. So this is the problem, and we saw that Master Chitti has solved the problem, but how it can be done in an algorithm basis logic. The first thing is about is whenever you want to train the machine, you need to go for machine and deep, that is different, but you need to go for the methodology of training. Methodology of training, you have two concepts. This one is supervisory, unsupervisory, and most importantly, reinforcement. So I'll talk about reinforcement later on. So supervisory, unsupervisory, and reinforcement. The supervisory is nothing but supervisory when the inputs and outputs are known, we call it as a supervisory. And unsupervisory, we don't have the outputs, only we want to process the input, we need to go for an unsupervised supervisory. Reinforcement is something a next level of supervisory. We'll deal with the next case study about that. So now this is a logic which we have to be taking care here. So now we have to apply the algorithm. So the training methodology, we know this is the inputs, these are inputs, and output is human. So we know what is the input and what is the output. So I'm just going for a supervisory model. We'll go for the supervisory model. So we normally go for the supervisory model. So this is a logic which you have to be taking care about. So supervisory model. So input and output is defined. So now we'll solve it in terms of a machine learning approach. So in the machine learning approach, the things are very clear about it. So we need to manually calculate the feature extraction, which is being done. So the feature extraction, what is done here is like body scanning, cutting off a head, cutting off a body, controlling the sweat, breath rate, and finally the rotation of head. So here these features are manually calculated, and we assuming that it is manually calculated some formula, and we have a threshold for the robot as well as for the human. Let us assume that. So for that, I just make it as 1 for robot and 0 for the features for the human. So I'll consider this as a mechanism. So for that, we need to prepare a data model, and the data model will have body scanning. Have the body scanning, and we have a sweat control and have a breath control, and then we have a logic of mechanism what we call as breath control, and then we have the cutting of the human body, and then we have the rotation of the head. So all these things put together as a one thing. I just for the robot, for the 100 robots, we can make it as if there is a metal body, make it as 1, right? If there is a metal body, I'll make it as 1, and there, if there's so it is for the human, so make it as an opposite 0. So it is there should not be any sweat, and there should not be any breath. And if it cuts the head, it is metal. If it is 1, in the rotation, it can rotate the head, so it is 1. And then we have for the human, right? And for the human, there should not be any metal body, so 0. And I just reverse it for 1. And again, if we have breath rate 1 and cutting right, it will shows the blood 0. And the rotation, we can't able to do it to 0. So that's the logic we have to consider the data. Now labeling. So label here is we need to present what is this output for the training model. This is the logic which have to be taken care over here. So I just make it 1 for the robot model. This is 1 for the robot, and here we have 0 for the human. So now the data model is ready, and these data models are required for training your machine. Now my basic question is, sir, after the data model is ready, you can see in the film. Body scanning fails actually. Even though this feature fails, sweat it can't able to identify, breath rate it can't able to identify, the cutting of head it can't able to identify. But we need a learning model which can able to understand from the one single distinct feature to make a difference of data from the similar group of data. So this is the most important for us. So here, even though the body features fails, even though your sweat is, it can't able to identify. You would have seen in the film, it can't able to identify. So there is a body cutting, and there will be a sweat, and there will be a breath rate, and there will be a cutting. Like everything, the process step by step takes place, and each features fails because my learning model doesn't identifies that. But the learning model learns and identifies with only one single feature, and that feature is done with the help of rotation of head. So this is the most important cases. This is the rotation of head what we have. So this rotation of head is important for us. The rotation of head is important for us. So you need a learning model. That learning model is important for us to understand the logic. It's very, very important to understand the logic that it should learn with one single distinct feature. So with the help of a one single distinct feature, it should learn by itself. And that is known to be your support vector machine. Hope you can identify what a support vector machine is. This is support vector machine. This is the logic what we have right now, the support vector machine. The most important for us to understand the logic what we have here, the support vector machine. The support vector machine is normally utilized for the identification of this kind of a difference data from the similar data, and it is a powerful and old and powerful machine learning algorithm which is predominantly utilized for this kind of an application. But I'll tell you how where it is utilized in deep learning. So now you should understand whenever you want to find out an SVM for this. So SVM is normally utilized to understand the difference of data or need to classify the difference of data from the group of similar data. And it can learn with the one single distinct feature. And when you look out for the mathematical side of aspect, you can see an XY will consist of the plots of the plot features of different models. That is of a different categories of robot and the human. And if you draw the hyperplane between to differentiate with the, you would have seen in this, there is a hyperplane which makes the difference over the feature. The one single feature which is like close to is rotation of the head. So you should understand by only with the one single feature it can able to understand, it can able to classify. So that is the application of SVM in the image processing technique. So you must aware about this. So support vector machine is the next level. First level, what you have to understand for this kind of an application. This is one kind of a machine learning approach. Right. So any doubts regarding this? Hope you can understand what is the logic. Yes, because we are moving to the lot of algorithms actually and the implementation, deployment and everything. Hope you would have understood this, right? So now we are moving on to the next mechanism. Next mechanism. So next mechanism. This is your now my I'll play the video right now, and it is up to you to answer my questions. Right? Please watch this video carefully. So next case study. So please watch this. So please watch this conversation. It's most important, and it will identify the drawback of supervisory model. So the instruction is being stored on the machine, and the machine fix its brain or a CPU that it should listen only to the scientist Bora. So the output is Bora right now. In the previous scene, the output is Bora, and it has never learned from the dynamic environment. So this is the major drawback of supervisory model. We'll talk about this, how it is rectified. Right. So you have seen this thing. Actually, we will go for this case study. Questions for you actually. What is the problem in the scene? The same thing. What is the problem you identified here? So this I need like answers from your side. What's the problem? What is the problem, guys? Actually, yeah,
Saving people from the fire.
that's an application. That's fine. Actually, right? Exactly. Good. Then anything else? It doesn't recognize the human. That's fine. Okay. Anything else? Human feelings. Okay. Then.
It just stick with the instruction which is given by the human, and it doesn't do any kind of analysis.
Oh, okay. So it is only related to the input given by the human. Okay. Good answers. Right. Super. Right. So yeah.
The
So now,
sentiment analysis is not there.
oh, sentimental analysis. Good. Okay. So even human doesn't have the sentimental analysis, right? Okay. Like the jokes apart. Okay. So what is the algorithm? Whether it is supervisory or unsupervisory? It's supervisory
Supervised.
or it's a
Supervised.
supervised. Okay. How?
Because he knows what the output is going to be.
Okay. Okay. That's fine. That's fine. Okay. Okay. So good. Right. Hands up. Actually, right. Okay. So here, like, it's a supervisory. I'm happy that you have understood. Good. It's a supervisory model because uh, the thing is, it is why it knows what is the input and what is the output to be done. Here, the first question, problem. What is an exact problem? We'll talk about in terms of technical side, and I define the problem when the scene starts actually. The problem of supervisory model. So it may be like a human emotions and everything, but the problem of supervisory model, right? So I'll discuss this algorithm and then come back to the problem here. Now we'll solve this. Let me share it. So now, like the second case study about all these things is like we need to understand what is the logic which we have taken here. Here's it's a supervisory model. Supervisory model with the output be the people to rescue, right? If they are alive, that's the most important. This is what the instruction given by the scientist that whoever is alive, we have to rescue it. So we need to rescue for this, and we know the number of people. So input and outputs are known. So this is a logic what we have to take care of it. So input and outputs are known, so we can able to do the kind of an application. So it's a supervisory model. So what happens is the first thing is it has to find life of people, right? Liveliness of a people. So habit measure, assume it sees the face recognition, whether the human talks, even like we'll add some added features. That is, we can add some features of measuring your breath rate and everything. So if all things are there, it proves that he's alive, and we have to rescue it. And the rescue that it checks with the magnetic field and everything that we called as a voting mechanism. And if it is there, it goes and rescue it. This is the logic. So now, this the two conditions there to solve it actually. The first condition is applying the conditional classes on the data. So the applying the conditional classes over the data. That is the most important what we have. The conditional classes over the data. So the conditional classes for the data is very important. Applying the if condition. If he has a breath, then if he has the face is recognized. If he talks. So the conditional classes is applied on the data to identify he's alive and take a decision. And this is called, my dear friends, this is known to be the decision trees. Most important, right? This is all called as a decision trees, applying the conditional classes over the data. We have extracted the different features, and these features has to be checked with a lot of applications what we have. So this is known to be the applying the conditional classes for the features what I apply, and that is done with the help of a decision trees. This is one methodology. And the second methodology what we have is you're applying the probability theorem. That is the probability theorem, and that has been done with the help of Bayes theorem. Applying with the help of the Bayes theorem. This classifier is known to be NB theorem, that is naive Bayes classifier. Naive Bayes classifier. This is the logic what we have to come across here. This is the mechanism what we have to take care about it. So this is NB classifier. This is NB classifier. NB classifier applying the probability theorem over the data, alive or dead. Finding the probability of alive and dead. If it's alive, go for a solution. Otherwise, leave as it is. So this is applying the base theorem on the probability, identifying the probability, and that is known to be the naive basis classifier. So that is the logic which we have to take care about it. So that is the mechanisms for the what you have to understand for the logic. So these two are the most important machine learning models which is utilized here. But what is the drawback here is we have two problems can be stated over here. This problem is if you leave any kind of a conditions over the data, then it will remain to the fatal. So this is the logic what we have to come across here. So why? Because this it has not been properly, I got some answer, it has not been properly given an instruction that it has to rescue the people with a dress, right? With a dress. So what happens is it looks only whether he's alive. It doesn't check for the environmental conditions, and it doesn't take the wise decision. So that is the most important, right? It is the most important for what we have in terms of the decision tree and the probability theorem. That is, it checks only the conditions given. It is not going to learn from the outsiders. It is get only with the conditions given. This is one point. Second point is, since inputs and most importantly outputs are fixed, so this is the major drawback of supervisory model. So since output is fixed, right? So it fixes its output that it has to be that it is rescue from the people, that rescue the people. That's all. It doesn't know about how to whether you to be on the dress or something else. It doesn't interact with the environment. So the self-learning is not possible. It's not been integrated in a supervisory model. So this is the problem what we have here. So how it can be overcome? The supervisory model, because kindly remember, once it has to be trained, it should get updated, right? When I train a guy with the logic, when myself is trained, I should get interact with the environment. My brain should get updated. Otherwise, I'll be out of the market. So please remember, so now the algorithm is changed. Now we have seen the two important problems. One, the inputs are given and it works only for the inputs and instruction which is given. And that is due to the supervisory model. Second, the supervisory model, once if you give any kind of input and outputs are fixed, so it will work only on this area. It will be trapped between these outputs. But when you want to make the algorithm to understand and interact with the environment, with the dynamic environment, gets the output and changes accordingly, then that is the most important thing. So nowadays we are moving on to the, instead of supervisory learning methodology, we are moving on to the next category that is called reinforcement learning algorithm. So reinforcement, most important algorithm in today's world. So now I'll give you some example how the reinforcement works. Yeah, so I'll just give you the example how it works. Right. Please watch this. Now it gets an instruction. Its model is fixed. It works. So now my machine interacts with the scientist. So it is working normally. When it is a supervisory model, it works normally. But my machine is interacting with the environment. That is, it should work according to the scientist. Now you can see here, it works accordingly. This is reinforcement. This is most important. We have agent and reward function. We'll talk about detail, right? So here, this is the reinforcement methodology. So I'll repeat once again here. I'll just with an example you can understand. So here, watch it like. So it gets it. So walking style is stored here, and my machine, okay, it stores and it works according to that. My supervisory model is fixed actually. So it works. Now, if it is the supervisory model, my machine will not interact with the environment, and whatever the do not listen it, and he walks according to his wish. But what is exactly happening here is it listens to it, yeah. So now it adapts to the environment. It adapts to the environment, right? This is what we call as a dynamic programming. It is called adapts to the environment and alters as it regularizes to the scientist. So this is the logic what we have here. So it again it changes, it works normally, and again it changes according to the scientist. So this is known to be the reinforcement. Right now for the reinforcement. So nowadays we are working on a kind of an application, and we are working on kind of a reinforcement logic. So hope you can understand what is the problem in the supervisory model, as well as in your like what do you call like the problem what we have, the mechanism. Now the second thing what we are making to understand, hope everyone have understood. Now I'm going for the next level of an algorithm, how it can be done. So now you can understand why we are going for supervisory, what is the drawback in supervisory, and why we going for a unsuper, that is your reinforcement. And all the game development and all your video processing, there is a kind of a reinforcement logic. So the reinforcement working is being integrated nowadays, and working on reinforcement, it's a little bit complex, but still you can do it, right? So now you can understand what are the problems. Now we'll move on to the next level actually, right? So let me go for this here. So we talked about, so next application is about ANN. So artificial neural networks. So this is the mechanism what we have right now. So neural networks. Right? So the neural network is important. So the logic is most important for us. So the artificial neural is the base for everything, and it is the base for your deep learning algorithm also. It is for the deep learning algorithm also. What is this exactly about this ANN? So ANN, very simple. We'll solve this inputs supervisory model, but you can make it in reinforcement. I'll tell you how to do this. So inputs there, and then we have a brain for processing it, and then we have an output. Very simple. So the input are considered as the input features. And then we have a brain, so we don't know what is happening in the brain, so it is known to be the hidden layers. So this is called the hidden layers, which since the brain consists of numerous of hidden neurons, nodes, and everything. So similarly, we also construct these layers with the nodes, with having their value, with having their numerical values, and that numerical value is being substituted in a trial and error method, so that I can get what is the exact output. So then the output. Right, then the output is defined. Now what happens here is, now we have this kind of an application. Let us consider how we make it out is, let us consider identify the problem. Next here is to identify Aishwarya, right? Let us assume you need to identify Aishwarya. So we will take about input features, we'll calculate mathematically, right, the phase and everything, and then it is given for the hidden layers to clean it, right? So you make the children to understand. So since it is Aishwarya Rai, right, the kid and a generation like us can understand easily by looking at one time, because we are keep on seeing here, and we are keep on our ears are audible to about her news. So here that decides your hidden layers. For this, I just make it out input, and only one single layer to identify Aishwarya Rai. I need only one single layer, hidden layer, right? And then what happens is, right? And then getting the output, the Aishwarya Rai is identified, right? This is the logic, right? This is simple logic to identify Aishwarya Rai from the human. So here by the human. So input features are extracted because we are hearing the news and we are seeing her face and everything. So only one layer is important to understand. Okay, so we are okay. So the mathematical model is designed with single layer and the output can be uptime. But now think about a situation here. We have Aishwarya-like person, like the similarity of Aishwarya Rai, right? So what happens is we need to study the large number of, like, what happens here is we need to understand their characteristics so that I can pick out the correct Aishwarya Rai. Because even when you see in the backs, when you see someone like Aishwarya Rai 1 or 2 or 3, there are the group of features will same alike. So we need to identify the good Aishwarya Rai, the real Aishwarya Rai. So what is happening here is I need to train my brain with a lot of data about her, eyes, nose, and everything. My hidden layer normally increases. Let us assume instead of a single hidden layer, I'm going for a hidden layer. Depends upon an application to get the output. What happens here is you can see here from this and this, the single input layer will have the less complex, but we are getting an output. But in implementing n hidden layers, maybe output is uptime. But still, what is the logic? If I go for the large number of Aishwarya Rai, like a large number of faces like Aishwarya Rai, this single hidden layer will not be sufficient to get the correct output. That is what we call as accuracy. So we need lot of training on the brain, and that has been done with the help of n hidden layers, right? And this concept is known to be your deep learning logic. So I'll repeat once again. So in general, you can understand what is the artificial neural network and what is the deep learning network. The artificial network will consist only of the what you call limited number of hidden layers where you can process different things. But as the data increases, we need a lot of hidden layers to train our brain to get the good accuracy, good results. So for that, we are just moving on to the hidden layers. And n number of hidden layers, and that n number of hidden layers is being called as deep learning logic. Otherwise, I'll have another example for you. For example, if I want to get a good 50 marks, right? 50 marks as a percentage for a pass. So my input is different and my training of hidden layers is different. I used to keep up only with the keywords because I need to only get the 50 marks, right? If I want to get 100% of marks, full marks, my inputs and my training layer will be different. So that is the logic what we have. That is the logic why we are preferring a deep learning. That's why we are calling. Even though the volume of data is increased, we are getting a different kind of application. That is the huge number of hidden layers are there to get a good percentage of marks. So that's the layer which we have over here. That's why we are preferring the deep learning algorithms. Now the deep learning algorithms, we have two categorization. One is CNN, for the video analytics, and the GAN, and for other time series data we have STM, RNN. Nowadays we are working on the transfer learning. This is the most important cases. It is a transfer learning. I'll explain you what is transfer learning with help of a CNN. So now this is the logic which you have to taking care here. So what you come across here is like what you call the CNN, convolution neural network, and GAN, general adversarial networks, and LSTM, long short-term memory, recurrent neural network, and transfer learning methodology. Now, what we are going to see is about CNN, because I'm very new to GAN. I just started working with the GAN. So my experience working on GAN is a little bit less, but other algorithms, I'm working with all stuff of application. Now, I'll just explain. We'll start with CNN. CNN is a convolution neural networks. Now, again, we are going to play the video. For understanding convolution neural network, we are going to play the video. So let us assume the formula here. So the convolution CNN is nothing but convolution feature extractor trained by neural network. So trained with the neural network. So trained with the neural network. So the logic is very important for you. This is the formula you should remember when you work on CNN. Convolution extractor with the neural network. Now, what is happening here? What is the logic we are happening here? I'll play the video again. You can see here, and then we can go for it. I'll go for the video here again. I'll play the video. Right. So this is the most important. So can anybody tell me like what is happening here in this video recognition, motion recognition? Can you tell me what is happening here? Actually, right? So can you tell me what is happening here? I don't want like the other explanation is over reinforcement, but what is exactly happening in the video here? Any answers? Any answers, guys? So you can see here a video or a frame, one frame, and you can see some image, right? What is happening here? Any answers?
It captures that scientist walking style.
And that it captures, that's fine actually, it captures it. But my question is, what is happening here? Captures it. What is happening here actually?
It just
This
side by
is
side
one.
encompass yeah, both human structure along with the robotic structure.
Okay, then anything else?
And moreover, there is no node has been detected. Like for human, if you take shoulder, means from that shoulder point that have some movements, right? So in robot, there is no nodes has been marked out.
Okay, okay, right. But I'll explain you in different categorization, right? I'll explain you in a different way, right? See here, the image is taken. So what happens is it scans your image, right? Now you can see here some of the background images are being extracted. So some of the background images are removed and the thing is converted into skeleton. Skeletonization is taking place and it compares with the robotic model. This is what is done here actually. So what happens is you can see here these shoulders and all these things are converted into a skeletal images, skeletonization. So and background images and everything is being removed here. And like what is the logic here is these images is now is being skeletonized. It is being skeletonized. Skeletonized in sense it removes all your dresses and everything. In short, we can say it is an edge detected. Right, edge detection. Simply, it's not an exactly edge detection, a simple edge detection, because it subtracts every image what is required. Now it is converted into a skeleton methodology. Now, how it is done? So, what is the logic which has been done over here? We look forward for that. So now here we saw something on first thing is about skeletonization. So now I got it like the video. Images. Now we have a video images actually, right? And that images, let us assume it is in terms of matrix. Something on matrix, right? It is comma actually. Sorry. Something on values, right? So one frame is taken with matrix. Now I need to get the skeleton or all these things, background images, everything has to be subtracted. So ultimately the filter comes into the picture. So here we have to use a filter bank. The filter banks comes into the picture, which is utilized to extract that feature. It is utilized to extract that features actually. So that is the logic which we have to take care about the mechanism. So it is the logic which you have to be taking care about the mechanism. So here the filters banks has to be substituted to get the images. For example, let us assume it is your trial and error based on the application. You can use it out either 2x2 or 3x3. So let us assume I'm using it for the 2x2. 2x2. So what happens here is this matrix will be multiplied on the first row and column. So the row and column will be multiplied with the kind of a matrix. The row and column will be multiplied with this. So we have multiplied and accumulate. The multiply and it is added. That is the most important scenario what we have right now. So that is added. So 1, 2 and 4, 6. -2, -1 and -3, -1. that two matrix or multiplied and added will get some value over here. So this is the value. So this value will be obtained. So skeleton has to obtain here. So based on the output, what is to be obtained? Substitute your filter values. Substitute all your filter values. That is the logic which we have to be taking care about it. And now it has been shifted to the next row, that is 2, 3 and 6, 5. So again, the value will comes over here. Again, 3, 3 and 5, 7. Again, the next column, 4, 6. Next row, 4, 6 and 5, 7. So again, 6, 5, 7, 9. So these filter banks are rolled over the images or the frames of each and every images of your video. So here, this will be rolled over the each and everything, and it has been given over here, and we'll get some values, some matrices over here. And this is the most important matrix which we filter the noises, background images, whatever is wanted. That is being clearly obtained here. Now you need to go for the segment. Then we need to go for a segmentation. So segmentation is nothing but your background separation is over. Now I need to go for a skeletonization. So there is a formula for that. For that, in your mechanism, we are going for pooling layers. Here we are going for a pooling layers. The pooling layers are important. After the pooling layer, the segmented images will be taking care about it. Hello?
So can you please repeat this concept again?
Yeah, which one, ma'am?
So this filter bank thing, you
Okay,
are
I'll explain.
multiplying the matrices or adding or both?
No, like we have to multiply and add both the things. That is the convolution. Clear, ma'am?
Sir, how
it's a
we do
convolution.
that?
For example, here the first line, like 2, 3 to -2, -1 and -3 and -1, 1, 2 and 4, 6, right? It will be multiplied, right? Clear, ma'am?
Okay, sir.
Right, it will be multiplied. Then it is go for that in the first row, 2, 3, 6, 5. Again it is multiplied. Again 3, 3 and 5, 7. Again multiplied. And all these things put together added as a one value. Clear? So first row will be reduced. So dimensionality will be reduced here. Clear?
We are multiplying the two columns, or we are
Yes, ma'am.
multiplying that video image with the filter bank values.
Only with the filter bank values.
Okay, we are like we'll be multiplying here one with -2
And -1, -3 and -1.
Okay, we are multiplying each and every cell with the whole filter bank.
Yes, that is important.
Okay.
That is what it is sandwiched. It is being sandwiched, right? So it is should be rolled over the whole images and frames.
Okay, sir.
Right.
Thanks.
So that is the matrix we'll obtain here actually. Again, a numerical matrix which we obtain over here. And from this matrix, we need to identify, we need to segment it, and that is being designed based on the pooling layer. And this pooling layer will give you the segmented images. So that's the most important, the segmented images what we have. And from that, we need to identify the different features. What is the features to be extracted? And from the features, you can extract with help of max features. You can take the maximum intensity or minimum intensity, whatever the features you want, you can able to extract it, and you can do the application. Max and min features and everything is been done over here. So that can be taken into an account. I'll show the video again here. Yeah, so here you can see here. Yeah, now you can see the concepts over here. So now it is skeletonized, pooling layers, and with the help of filters, I can able to make it out. You can see here the red dots of all the things, and here this is the cases, red dots of the joints which represents over here. This is to be identified. So this speed and everything has to be identified. Since it's reinforcement, it interacts. That is different. But manually, when you're working over here, this has to be identified. This is the logic, right? So the red dots will represent the max layer of max pooling layer of this, and the features are extracted. This is what the logic which we have to give here. So here I'll just repeat here, this images is skeletonized, background images, everything is done with the help of a filter bank. And from the filter bank, it goes for the pooling layer. And from the pooling layer, it has to understand what is the feature is really required. and the pooling layer has a different categorization with the max pool layer, with the min pooling layer, linear, everything. So it depends upon our application. We have to substitute here and get the required segmented images. So here you can see the segmented images is obtained over here with the red dots and green dots and everything, so that the speed of the motor can be adjusted or can be learned with the help of the input what I obtain from the environment. So this is the feature maps. So these feature maps are now is been given for So now what we are going is, after learning, after extracting all the features, now the feature maps are being now given for the logic. What we have to take care about the logic here is, it has to take a mechanism. It needs maps. Feature maps are extracted, and then it goes to the neural network training. This is what is called semi-connected layer. This NN, neural network, and it classifies. Simple, right? So it is a whole structure of all the CNN right now. What happens is, in the CNN, so as we talked about, C plus NN is being utilized. So today's world, we are using a backpropagation algorithm. So for the training the logic, the traditional backpropagation is being normally utilized. What is exactly about the backpropagation? The backpropagations are nothing but a very important thing, that it has to interact with not an interaction. It has to, when the threshold is tested. For example, you just define your students to get a 70% of mark, but unfortunately he gets 60%. So what we do, the difference of 10, in order to make him to boost up from 60 to 70, what we normally do is we just again train him, so that with the percentage of, we know how to train to get the 10 marks, right? So that is known to be the backpropagation. A similar way, the backpropagation, when we set a threshold that it has to be identified, and the error is being calculated for every iteration, and that error, based on that error, the tuning property, it will be taken as a feedback, and the parameters, what I call the hidden neurons, what we call, will be tuned and trained again and again when it meets your threshold. A similar way, we're making the student to get the good marks. In the first attempt, he can't able to get it. Next level, third level, fourth level. It depends upon the mentality of the brain. So we'll keep on training him until we get a good percentage. A similar way, when we take the threshold, what is to be obtained, if it is not been met, when there is a kind of an error, that error is taken as a feedback and it is being utilized to train your model. And what happens is, even though we are getting a good percentage of good accuracies and good results, but what is the major drawback here is the time complexity. And when you keep on training it, the performance normally degrades. So this is the drawback in the backpropagation, even though we will get good results. In order to overcome this, we have another methodology, C plus NN, pure feed forward mechanism. This is the next level, that is called feed forward mechanism. The feed forward, the name itself indicates what is feed forward. There is no kind of feedback here. We'll pick up a good student and train them, get them good marks. This is what the logic is. So there is no kind of a backpropagation. So by the single mechanism, we can able to get the good marks. That is a good results. That is feed forward. And one such powerful feed forward layer is something on LM, extreme learning machines. This is most important what we have. This is extreme learning machine. It's most important because this is very single feed forward layer. Actually, it is a single feed forward layer which is normally utilized to train the machine. It is normally utilized to train the machine. So that is most important for kind of an application. So here, this CNN, now it is replaced with the extreme learning machine. It is most important auto tuning property. That is, it can say, like I said, as I said before, that we have to substitute manually for the values. But here, the extreme learning machines, the values of the hidden neurons can be substituted automatically or randomly assigned to the value, randomly assigned to the nodes. That is with the help of pseudo inverse matrix. So that is the most important case of extreme learning machine. Now you can see that convolution neural network is getting modified for each and every vision system. And then if you have been so confident about it, what the CNN nowadays, convolution neural network, convolution feature, that means SVM has a powerful feature to identify from the single decision feature. You can elaborate or you can combine here. C plus SVM. That is, we are convolution feature extractor and trained with the help of support vector machine. So now this is the logic. The deep learning as well as like your machine learning comes into the picture. You can ask me the question where I use a deep learning here. You must understand the number of filter banks and the pooling layer and everything is depends upon the output what I obtain. It is most important to get the good output. If I don't get, it is not mandatory that if I get a good output in one, it is possible. You need to add numerous logic. What is learning logic? So the training is done with the help of machine learning logic.
So you're muted, can't hear you. Is it a break?
I think it's network issue.
Okay, thank you.
I'm sorry, like there was a network issue. Sorry, I'll repeat once again what I explained to you actually. I've been keep on explaining about the plug and play model of this boosted algorithm. So please make it note of that. The back propagation is something like identifying and just changing your group, like changing the network for this kind of an application, and we need to go for a mechanism. But in case of a boosted, it will never alter your network. Instead, it will boost your output. It depends upon the threshold, what is uptime. So here it is being given over here. So now you can use the 2 algorithms for a hybridization, or even a 3 for getting a good result. This is a formation of new algorithm. So this is one kind of a thing what we have right now. Second is like getting the good features. Getting the good features, that is most important, because you have a lot of features with that. We need to identify only a good feature which has the impact over here. For that, the convolution is being now being integrated with the optimized features plus a training model, any training model. So any training model. So the optimized features optimization is nothing but a requirement of implementation of the meta-hysterical algorithm, or we can say bioevolutionary algorithm. Such as, like, we have PSOs, we have genetic algorithm, we have a lot of algorithm, right? ACO, ant colony optimization, bat algorithm, whale algorithm, lion algorithm, wolf algorithm, gray wolf algorithm, lot of algorithms, cuckoo search, butterflies, lot of algorithm. So these algorithms are applied to find out the best feature and also to make it a clear-cut understandability of a mechanism. So this is another case what we have. So applying the since I told you the feature maps can be applied, so a lot of features can be applied, can be obtained. So in order to take only the important features, you can implement in between the layer, you can integrate this bioevolutionary layer to get the good accuracies, to get or to reduce the burden of your network. At the same time, it should not compromise with my results or a performance. So by taking these 2 points in your mind, we can able to insert, or we can able to integrate this kind of evolutionary pattern for a selection of best feature which has the impact on my network. This is another criteria what we have actually. So this is another criteria what we have, and this is a logic what we have to take care about it. So now next application is we are going to see something an advanced level of video analytics, video mechanism. So I'll explain you how it has been done, right? So please watch this, and there will be a question for you again. So please watch. I'll just play you the 2 important scenes, right? 2 important scenes of this movie actually, right? I'll play this. Right. Please watch it because it is important. So please watch it. So here it scans the images and reads all the numbers actually. First thing. Now the first scene, it reads the images. It reads your images and store it on it. Right now, watch it carefully again. I'll play the next video for you. Right. Please watch this. So second movie, there is an interconnection between these 2. Please. Watch this conversation. It's important. Right. So it gets the data from the telephone and it stores it. And the question is asked, it relates to the number, what has been stored there, and it answers the two answers for the question, right? It answers what is the Fibonacci, as well as the machine says that. Plus this is most important. Actually, like we saw a lot of formation of algorithms, but still there is a mechanism which we have to take care about it. First, I'll list out the problems, how it has been done in the scene actually. So what happens is it's purely of document scanning, like so document reading, and the machine understands it has been stored in some memory and it compiles. So it never updates it, right? It never updates it, right? Most importantly, learn it like it doesn't learn, and it stores the two numbers actually. For example, so we used to find out the Fibonacci series. So Fibonacci series is some number over here, and the phone number is also been stored here, right? And something on that. So the same number, right? So what happens here is my machine is able to identify this number which is already stored on my memory. So it relates that it is not only a Fibonacci series, but it is a phone number which is being stored, which he scans in the spa area. It scans the telephone directly in the spa area. Now, what is this like? What is the logic? What I'm trying to prove here is, so here the thing is, first thing is you have to understand whenever you have this kind of reading a books on the images, on scanning an images, right? How it is stored and what is the functionality. The first problem, as we talked about on the videos, the first thing is about the document once read, right? One read by the machine. What has to be taken care here is should not be. We can make it as not to be updated every time. This is what is the logic, right? So this we have to correlate with every time. It should not get updated, right? If it says the Fibonacci, there must be a scene like it can stop only for the Fibonacci series or not. But my machine relates with the phone number which is already been stored. So the first thing what you have to take care about the text reading by the machine, you need not update everything. Once it has been trained, it should learn only the new word, not the keep on training with the old words. I'll give you the another sentence, another video which can clearly explain you this concept. Now you can see here, yeah. So the new word is recorded. Only the new word should be recorded. And all other things, if the words are trained, it should not be get trained at each and every time. So for example, if this man answers questions the machine answers its own way because it understands and it replies back with the data what has been stored. But the word which has been given by the human, it doesn't know that. So only it identifies the new word and only it gets their data. So every time you have to remember while we are working on the text analysis or the text reading, so we must able to understand that every time once it has been trained, only the new words has to update itself for a kind of a logic, and all other thing the machine has to recognize. This is the mechanism. So one time training is important, and after that the machine has to understand by itself these are all the new words and this is to be the sentence to be formulated. So this is the logic which you have to be taking care about this mechanism, and this kind of technique is more utilized for understanding your OCRs, that is understanding your optical character recognition and digging out the older letters which is before 5,000 or 10,000 years in archaeological society, archaeological survey. You can utilize this kind of a technique. So how it is being utilized? So this is the most important problem whenever we work on the text. I repeat once again, it will be like trained at once, and finally when there is a new sentence and the new word, a machine has to identify. It should run parallelly that all the words which are there, if there is a new word, if there is old words, it should get updated by itself, and then finally if there is a new word, it should update. So this is the logic what we have to take care, because whenever I update each and everything with a separate mechanism, my machine's memory and the memory complexity will normally increases. So in order to overcome this, what kind of a model can be utilized here? Let me give you the idea for this. The idea here is very simple, actually. So I need to scan the image here. Convolution, right? And then here we are going for LSTM, right? We are going for LSTM, long short-term memory. So this is most important, and we have a model for this that is called BERT model. Called BERT models. BERT models are nothing but bidirectional encoder receiver and transmitter. So these BERT models are being utilized for a kind of identifying the document from the mechanism that it can read from either the past and single thing. But the thing is, we have to remember, once it updated, once it is being read, again when it reads for the next document, it should remember the first one. In accordingly, it should learn and it should update it. So this is the most important, whereas the LSTM plays a vital role. And now we are being moving on to the transfer learning. This is where the transfer learning plays an important role. So the transfer learning plays a very, very important role for this kind of an application. Little bit tricky actually. And here it has been done with the help of learning with the reinforcement. Reinforcement along with the PM. This is the logic what we have to come across here. So this is the mechanism. So here for the kind of documents reading and find the kind of an application what we require. So this can be understood and this can be made over with the kind of an application. So this is another model, LSTM. So LSTM is normally utilized for a time series data, but for this kind of a document reading and find this kind of a high-end learning, self-adaptive learning of your letters and understanding the letters, these models can be utilized. So these models can be utilized to understand. So this is the next thing what we have come across here. So please remember, this is a little bit complex. This is where we are using sentimental analysis and everything. But my sentimental analysis is something different. I have to train only one single machine, and then it should get if it is an older one, it checks in the memory whether it is old or new. If it is older one, keep that as and learn from it. If it is new, update the mechanism. That is done with that for reinforcement. The most important and tricky algorithm which is available today, and most importantly, it is utilized in a case of your making your machines to understand according to the environment and read according to the environment as like your human. So this is what the logic which is happening here. And the next case study which is happening over here is so hope you can understand something which is advanced level of an algorithms. So next, I'll just give you the another case study which makes you to understand more clear about it. It's not about the document reading, but still how it recalls and how it measures the mechanism. Most important. Yeah. So please watch this. So this is the next level again. It's a most hybrid algorithm. So please watch this. So it's all compressed and the video is being live streamed over the network. Right. So this is the most important thing here. What you have seen here is the live video streamed over the Wi-Fi network. That is the problem. That's an exact challenge what we have actually. So now, like this is the most important problem what we have. This is my PPT, which can give you the clear picture for this actually. So now this is the logic. Like, so this is the next hybrid algorithms. We talked about CNN and everything. This is the next hybridization. So here in ultrasound video sequences, which has been taking over here is there we have an MPEG-4 compression, right? The Chitty considered that as a gateway, right? That is considered as a gateway. There is no kind of a cloud or a server. It's a gateway. So this is the logic what we have nowadays. We have a cloud system and everything. So before a decade, that there was a technique, right? So the machine is there and the gateway is there. Gateway gets the machine. So gateway gets the video. So here with the CNN, I'm just getting out the content. What is the important content and separate the background images. So background images and the content have been separated. First thing. And now you can see here a small cell network, which you have seen in the Wi-Fi, right? You would have seen in the Wi-Fi. And I'm just extracting the Wi-Fi's network parameters, such as the signal strength, throughput, delay, and everything. Now, what happens here is, depends upon the network parameters, the content will be scheduled to transmit over the network. Hope you can understand. For example, if the strength seems too high, if the number of users or the number of devices are high or low or medium, which can withstand a blend. So, and also the delay is less, right? So understanding the network parameters, my gateway understands the network parameter and sends the important content over the network. This is what is called content aware deep learning algorithm. That is, the content has been taken over here and the content is scheduled to transmit over the network. And here in the receiver side, it is being decoded and we have to see what is the video. Now you can see here, the quality of the video is measured with the parameter called PSNR, peak signal to noise ratio and similarity index. If the peak signal to noise ratio is high, it leaves as it is. If it is low, what happens? These data sets are manipulated. So here the reinforcement comes into the picture. So depends upon the network, the contents, the important content are sent to my receiver side. So here we implement a convolution neural network, and with the help of a scheduling algorithm, we have a different scheduling algorithm for that, and combining these two and learning with the help of a reinforcement logic. This is another kind of an application. Whenever you work on the video over the 5G or an IoT, whatever the kind, this kind of technique can be integrated. So this is all about your gateways. This is all about the gateway. Now we have a cloud centric, that is different. But here we have a cloud mega, that is a gateway, intelligent gateway, which can be able to transmit your videos by the reinforcement learning, measuring your receiver side as well as which is being transmitted. So where we can able to adjust the data set and accordingly it can able to transmit through the network. So this is the most important thing when you compare a vision over your what you called on the networks. So vision over the networks plays an important role for you. So this is all about the different algorithm. This is an hybrid algorithm what we have and what are the logics which we have right now. How to deploy this, where to deploy it, and how to deploy this we have to understand clearly. So the deployment is something different, and I don't know, like everyone is being utilizing your laptop and workstation. The first thing is about prepare your workstation. Preparing all these things, prepare your workstation with good internet connectivity, right? So many of us will wonder, like, I need to buy a good workstation or a good PCs for that. No need. Actually, my basic thing is if you have i5 processors with you, you can do wonders. So what is this? The training model. So in order to prepare the training model, is to be required, you can use Google Colab. It is a cloud-based GPUs are available for you, and it is like you can prepare your Google Colab training model, and or we have another tool called that it is paper spacings. Spacing. These are the tools which you can utilize your logic, utilize your training model for this. So training model is required, and from the training model you can download it to H5 and you can test it in your workstation using all the tools what we have, like Anaconda, like TensorFlow, Keras, PyTorch, and even Skycade. So I'm only familiar with not on the R actually. So these are the logics which you can make it out here. This is one kind of a thing, because if you have a good system, good workstation, you can train it continuously. But still, if you have low end, because it takes a lot of time and the heating, computing will normally increases. So I suggest you to go for interface with your Google Colab, get your space, GPU space, train the model there, get back to it, and you can do it. So this is the logic what I suggest you to go for it. And next is implementing in the hardware. That is most important. And before implementing hardware, let me list out what are the hardwares which are available. So for a machine system, Nano. So we have a Jetson Nano over here, and from the Jetson Nano, right? From the Jetson Nano, we have another board that is called MaxiPi boards, and finally FPGAs. So we have this. Another thing is Jetson Nano is an embedded GPU, right? You can utilize for a kind of an application, and you can utilize for a kind of any kind of mechanism over your network because it runs the TensorFlow, it runs your PyTorch, and whatever the case, it runs over here. So any kind of a programming level, like you can do a Python code on that, and you can even interface with the cloud. So here you can use it for a cloud system. This is one kind of approach where you are working on embedded GPU. Next is about MaxiPi boards. These are most important boards, low cost boards. In my NVIDIA Jetson will have a little bit costlier. It is a little bit costlier, but MaxiPi boards is considered to be the low cost board, but a little bit complex in working. And that has been done with help of MicroPython board. This is another programming which is available, which is called the hardware-centric application. Hardware-centric Python. So the MicroPython is normally utilized in this MaxiPi boards, and we have it is nothing but it is combination of, in short, we can say it is Python. So this is the next level of which is available. What is the MaxiPi board today? The architecture plays a vital role, and you can see in lot of news about this by architecture, which is most important for implementing your ML or DL algorithms for a vision system on these kind of architecture. So RISC-V architecture plays an important role for this, and we call this Androids. Right, so Androids will be utilized for this. So RISC-V architectures plays an important role for implementing your machine and the deep learning algorithms on the logic. So this is MicroPython based where you can implement all your sort of applications, but still I suggest you to go for the first thing. Get the training model, fuse it in the hardware, and see what is happening. And all these models can be utilized only for supervisory, not for the reinforcement. Still, we are working on the reinforcement, deploying on the hardware. So this is the logic, these two boards. Otherwise, you can start with Raspberry Pi. But Raspberry Pi is being utilized only for a short, that is, it is used only for a smaller version, not for the huge data, not for the big data. It cannot be utilized for that. It is utilized only for the small data. This is the logic what we have, and this is the logic what we have come across here. So this is the mechanism which we have been taking over here. These are the kinds of deployments what we have. So if you are not comfortable with this kind of a hardware, so you have a cloud for that. The clouds are providing a lot of services today. That is your AWS, Azure, and we have Google Analytics. Everyone is applying your ML libraries for you to work on that. And now you have, so you have heard about this word, MindDB. So this is normally you have a DB-like structure where you can integrate machine learning algorithms and deep learning algorithms over the data in the cloud system. So these are the things, and the mechanism is on Python, and we use OpenML and AutoML concepts for programming. So it's a Python based. So ML and the AutoML. When you want, if you have been not familiar with the hardwares, what is to be required, you can very well work on with the OpenML and AutoML concepts on the cloud system, getting the data in the cloud and doing all sort of things in the cloud analytics. So this is another kind what we have. A second approach, what I told you, it's a cloud centric. But here this is purely on the hardware centric, which you can work on and port all your algorithms what we have been discussed, except reinforcement, except the reinforcement algorithm. All the algorithms can be fused over here, and you can see what is happening in this case. So these are all the deployments. So I suggest you to go for prepare your workstation with this, train this model, and then test it in your workstation. And then you can go for the next level. You can build a device with the help of this Jetson Nano or a MaxiPi, or even terms of FPGAs. We have FPGAs which can support you for designing energy efficiency architectures with the help of even with the Python. So you have a lot of things to work on these boards. And if after that, if you are being not comfortable with the hardware, definitely you can move on to the cloud, where hardware is utilized to get the data from the hardware and store it on the cloud and do an analytics. So this is how the logic works on. So, and finally, these are all the tools which are available to get back into your deployment stuff actually, right? So here we have seen like a lot of algorithms, but only the basics, fundamentals to give you the how to look at these algorithms for different applications. So before reading any books, reading any informations, and reading any websites, I suggest you to look forward for this movie. Actually, look this movie. Actually, you can see, you can learn lot of algorithms, lot of ideas can be derived based on this movie, because based on the movie only I have taught you about everything. So you can see that movie, what is happening, and you can learn these algorithms in an efficient manner and in easier manner, right? So any doubts, guys? Actually, because like I keep on talking with you, right? So it's any doubts, guys, right now? What is difference between MicroPython and the Python programming, right? The MicroPython is completely of hardware centric. Actually, it's completely of hardware. So we have to write a Python libraries to support my architecture. But in case of a Python programming, we never bother about the hardware. Instead, it is a general libraries are available. You can write only the algorithm centric. But here in MicroPython, you need to make it and make you the architecture compatible with the different program, the different application. So you must aware about both the things. So MicroPython is use the Python. You can say Python for a microcontrollers, and Python is normally for your normal Python, which is utilized for the computers, right? Hope you can understand, right?
Yes, sir.
Yeah. Any doubts, guys? Shall I lift you for the doubt session right now?
Sir, nowadays most of the industry is using MicroPython only, sir.
MicroPython is very new, actually. Only few industries knows about MicroPython. Not about MicroPython. Not everyone.
Okay, sir. Sir, can you share your email ID, sir?
Yeah. So here I have mentioned my official as well as my personal mail ID. Future scope of AI. Yes, you have a lot of AI application, but still in India, it requires a lot of time, because we are not dealing with the massive data, because we talked about data everywhere. You're not dealing with the massive data. So AI will take time for us to handle it. And the future is all about AI. So implementing an intelligence over all the things, right? So please make it on that with the because a lot of courses are available. But still, I suggest you to go for the practical implementation, learning the models, implementing, deploying in the hardware. So if that can be done, then we can rule actually. Any doubts, guys?
So, okay. So thank you, sir. So now we're honoring the wonderful speaker, Dr. Athif Shah, with small virtual memento from our side, sir. So I will share, sir.
Oh, please, ma'am.
Wait, sir.
Thank you.
So now Pungulili ma'am conclude the session with the formal vote of thanks. Ma'am.
Just a second.
Thank you, sir. Thank you for your valuable presence. On behalf of Panimalar Institute of Technology, Department of Electronics and Communication Engineering, it's indeed our great privilege to be having you with us, sir. Once again, you have given us a wonderful session. I hope all the participants would have enjoyed this session. Thank you, sir. On behalf of Panimalar Institute of Technology, once again.
Thank you, sir. Thank you, sir. And the best wishes for everyone. And that too for the Panimalar, like they are organizing lot of webinars. I'm like I'm the part of continuous webinars. Actually, I'm happy that you people are arranging such a kind of webinars to interact with the people so that they can also learn what is happening here. So I just take a word, and this should be continued forever actually. And then and the dear participants, since I'm an industrial guy, right? So because there is a topic of low seed fund, I suggest you to go for a bootstrapping. That if you have a startup and you want to go for it, I suggest you to go for a bootstrapping. If that is a bootstrapping can be done, then you can go for a funding actually. So so I have a lot of things with you that with all the sort of things, but still again entrepreneurs, startups, like we have a different thing for you, but today we have covered only about the technical side. There are other issues which is the entrepreneurs are facing today for this kind of an application. So if the time permits, I can discuss what are all the failures we met with the video analytics and how we rectified and how we come up. So so that can be discussed if Panimalar has given the chance. Again, we can make it out. So anyway, thank you for this opportunity, and best wishes to Panimalar as well as for the participants to come with the flying colors with the ideas what I told you, and you can come up. Hope you can come up with a lot of flying colors over here, and I wish you all the best in your future. Thank you.
Thank you, sir. Thank you once again on behalf of Panimalar Institute. Surely we will also host several events. Thank you, sir.
Thank you, sir.
Dear participants,